Wonderful people, now that we have completed question 3, I think we should go to question 4. And in question 4, this is what we have. We are provided with f at x, and they say that this is equal to 2x squared minus 2. Let me just try to draw up a line. And we are also given g at x, which is minus k over x plus 1/2. And they are also drawn for us. Let me just draw these graphs for you. So this is what we have. Let me just do this. Let me just do that. This is C, this is A, this is B. We have an asymptote in here. Okay. We have our graph. Very good. We have our graph in this way. Okay. We have a point of intersection which we call point D, and the coordinates of D is minus 2 and 6. Alright, and then what else do we have? Okay, just to name, this is Y, this is F, and this is G. And we are told that A and B are the x-intercepts of F, and C is the y-intercept. As we can see, the y-intercept of F. D, with the coordinates minus 2 and 6, is a point of intersection between the two graphs. That is true. It intersects f at x and also g at x. So there is an interesting thing that we can talk about there. Now that we have this, let's try to define. This is a parabola, a mother graph that has been shifted 2 units down. So we know the values of C. We have g at x. If the value of A is negative, it will be on the second and on the fourth quadrant. The vertical asymptote is 0. The horizontal asymptote, it's 1/2, and there it is. Very important that we understand all this. Now in 4.1.1, they say we should write down the domain of G. Now the domain of G are the values of x that satisfies the parameters that are provided for us. Now looking at G and looking at the domain, which are the values of x, we have to see exactly what is happening as we are moving from left to right. This is an increasing function, and as we are moving in this direction, we can look at G. So we can say that the domain, remember this graph is moving in that direction, so this will be, it's moving negative infinity. Remember the values of x, negative infinity, the values of x, positive infinity. But we can see that even though we are going from negative infinities to positive infinity, we cannot exceed, or we can never touch the horizontal asymptote. We can approach the horizontal asymptote, that is true, but we will never and ever get there. So how do we restrict that? All right, we can say, since the value we know here it's 1/2, we can say, okay, the domain will be x is an element of real numbers, because we are moving from negative infinity. going to positive infinity in terms of the values of x. But we can say that x, the values of x as we are moving, remember this is a value of y. This is a value of y, and we are speaking about the values of x. So we can say that the domain, as we are moving in this direction, x is an element of real numbers. Okay, but now, is there any restriction that we have to provide for this? As we are moving from negative infinity is to positive infinity, x is an element of real numbers. Are we going to restrict ourselves here? Looking at this, are we going to say that x cannot be equals to 1.5? And what does that represent? It's the value of y. So we cannot restrict ourselves as we are moving in this direction. It's true that we will approach this line but never touch, but the values of x will keep on increasing in terms of the domain. And we can tell that x is an element of real numbers and x cannot be equals to 0. Why? Remember, we are speaking about g, and there is a function of g. X cannot be equals to 0 because if it is 0, all this is undefined. It is very important that we understand this. We accept any values of x going to negative infinity, any value of x going to positive infinity, but we must be careful that the denominator cannot be equals to 0. Therefore, even though we are accepting any values of x from negative infinities to positive infinity, x cannot be equals to 0 because if this is 0, the whole thing is undefined. Okay, that might have been a lengthy explanation, but it's worthy of noting. Now, in 4.1.2, they want the range of f. Now, the range are the values of y, and that also satisfies a particular condition in place. So, if we want the range of f, not y, now, the range of f, here it is. Let's look what is happening as we are moving from negative infinity to positive infinity on our function of f, because that's what they want. They want the range of f. Now, the range of f, I know the value here, it's -2. So I'm moving from -2 going in towards positive infinity. So the function is defined at x equals -2, because here if y is -2, I can find the value of x, which is 0. I know because it is a y-intercept. When y is -2, x is 0. So meaning it is defined at y equals -2. So I'm going to say my range y will be an element -2. And why am I making this a square bracket? That is to say the function is defined at y equals -2. At y equals -2, I will never and ever go down. At y equals -2, that's where my function turns going upwards. So it is defined at y equals -2, so it is inclusive in that way. Because the function is defined at y equals -2, we have a corresponding x value for y equals -2. Therefore, we make this inclusive bracket. Therefore, we say -2 is 2. Remember, look what is happening to the values of y. They keep on increasing, going to positive infinity. Are there any other restrictions that we can provide on this? We don't have to provide anything for this. There is no restriction, as you can see there. There is no denominator for y that we should say maybe y cannot be equals to 0 or y cannot be equals to whatever. It's not written in a fractional form. So we are just saying, also looking at the shape, the behavior of a function. Y is an element of minus 2 is to infinity. The graph is defined at y equals minus 2, and as I move, I can see that the values of y are heading to positive infinity. So this is to show that the function is continuous, going upwards. This is one way of stating this, or somebody can also say that y should be greater or equals to minus 2. What do we mean by this? We are saying, okay, accept the values of y that are equals to minus 2. The function is defined at y equals minus 2, and those values that are also greater than minus 2. Values that are greater than minus 2, minus 1, 0, 1, 2, 3, 4, 5. So this is another way of stating your range of f. Very important that we understand that. And then in 4.1.3, what is it that they want? The equation of the horizontal asymptote of G. Here is G, the equation of the horizontal. We have the vertical asymptote, x equals 0, and the horizontal asymptote, y equals 1.5. This is exactly what we have. Okay, so that is fine. Now what is important with this is to know that for the vertical asymptote here, this is the same as x plus 0, so the equation will be x equals 0. If maybe it was minus 2, you will say x minus 2 equals 0, x equals 2. And if you want the horizontal asymptote of G, you just take the value as it is. Since it is positive, you write it as a positive. If it was negative, you will write it as a negative. Something worthy of noting. And then we go to 4.2 now. Calculate the length of AB. I think that's what they mean. Let me just do this. Calculate the length of AB. Yes. Now, how do I find the length of AB? Now, in order to find the length of AB, it will be highly advisable for somebody to find first the coordinates of A and B. And A and B are the x-intercepts. Okay, so somebody will want to calculate the x-intercept of f, because A and B is on the function f. Right, so I have the equation f at x equals 2x squared minus 2. I know that x-intercept y is 0. 0 equals 2x squared minus 2. Take to the other side, divide by 2, and then your x is plus or minus 1. Now that we have x as plus or minus 1, I know that this will have to be negative 1 and 0. This will have to be 1 and 0. That's exactly what it means. X is negative on the side, and I know for x-intercept y is 0. The same, x is positive on the side, 1 is to 0. So how do I calculate the length of A and B? Now, let me make an example for you. I have minus 1 for A, I have 1 for B. Now, moving from A to B, there's a 0 there. It will take you 1, 2 units. So we can say the distance of AB equals x1 plus x2. And I can take the value here as 1 minus into minus 1. And I can say 1 plus 1, which is 2 units. And if you find this a little bit confusing, you can go to the distance formula and you know x2 minus x1, y2 minus y1, and you know that y2 and y1 are both zeros, so you can only work with x2 and x1. So you can say this is your x2 minus your x1, and you just square this, and this will be minus 2 squared, which is 4, which is 2 units, and you are very much fine. There might be other ways of finding that distance, but whichever method that works for you, we are very much fine with that. And that was 4.2. I think we can go to 4.3 now. Now 4.3, what is it that we want? Now with 4.3, I think what we can do, they say show that a equals -9. Is it -9? I think so. Show that k equals -9. Show that k equals -9. So we are here, we must show that k equals -9. So g at x, let me just do this. Very good. So we are very much here. G at x equals -k over x plus 1/2. So we have to show that the value of k is 9. Sorry, not -9, 9. Okay, so that negative times 9 will give you -9. So k has to be 9 because it is on the second and on the fourth quadrant. Okay, in order to show that, the first thing that I need a point for x and y that lies on G, and I have that. Fortunately, it's a point of intersection, D minus 2 and 6. So my y is 6 and my x is minus 2 plus 1/2. Okay, and then from here I can take this to the other side. 6 minus 1/2. Negative divided by negative, it's a positive. I can multiply both sides by 2, so that my k value is this, and I just insert this on a calculator. And let me just quickly try to do that. I have 2 into 6 minus shift 1/2. And we find a value of 9. So it's true that k is indeed equal 9. That was not so difficult for us to find. And then we go to 4.4, and in 4.4 they say write down the equation of the line of symmetry of G with a positive gradient. Now the equation of the line of symmetry with a positive gradient, you just have to know if the gradient is positive, your m is 1. If your gradient is negative, your m is minus 1. Now it is an equation of the axis of symmetry. Sorry, it is the equation of the line of symmetry of G. So we go to G, and what you need to do, you write down the equation of a straight line. And when you are at G, you take the points, you take the values of the asymptotes. You have your x as 0, and you have your y as 1.5, and then your gradient is 1 since they said it's a positive gradient, and you substitute this where you see x and y. So your y is 1/2, your gradient is 1, your x is 0 plus c, and you'll find 1/2 equals the value of c. Y equals mx plus c. You write down the value of the gradient, which is 1 times x, that is x, and then you write down the value of c, 1.5, and this is the equation of the line of symmetry of G with a positive gradient. This is how you do it. This is exactly the way you should do it. Okay, now that we are done with that, let's go to 4.5. Now on 4.5, write down the values of x such that g at x is above f at x. Right. When we are here, it is highly important that we understand the following. So what we are saying here is that you find for us the values of x where g at x is bigger than f at x, where g at x is above f at x. This is exactly what we mean. So in my function, how will I distinguish the position where the graph where g is above f? Now when you come here and you check, this is your g and this is your f. Now where g is above f, I can see that in here, this portion, g is above f, but here g is below f. Very important. So I'm looking for a position where g is above f. And how do I show that? Now I can see this. I know the value here. Remember the values of x. I know x is -2 until at 0, because this becomes your asymptote. It will approach y exists, but it will never touch. So from here until there, the graph of g is above the graph of f. So how do I write that? Now I will place my x in between. I know that the values of x here are greater than -2, and they have to be greater than -2 but smaller than 0, because I will approach 0 but never get to 0. This is very important. I'm looking for values of x that are greater than -2, all the values here, but those values that are greater than -2 must be smaller than 0. That's a condition where g is above f. Highly important that we see this. Okay, having explained that, let's go to 4.5.2. Where both f and g increases as x increases. So where f and g increases, now I can go to my function and I can try to look at this. Where both f and g are increasing, the function is increasing when we are moving from left to right. I can see that this function of g is increasing as I'm moving from left to right. And let me see, okay, this one is increasing, that is fine, I don't have a problem with this. For g, let me see for f, where f is increasing as I move from left to right. As I move from left to right, the function is decreasing. I can see that. And from here going there, it is increasing. The function is increasing as I move from left to right, because the values of x are increasing as the values of y are also increasing. So the function is increasing on this side. Okay, so I cannot take this because it only meets the desire of g but not of g and f. But from here to there I can see that okay, f is increasing. What about this portion of g? As I move from left to right, let's see what is happening. As x increases, let's try to see this from left to right. This is also increasing. We can see that as the values of, for example, x there will be a certain value. Can you see that x is increasing? Can you see this? And as x increases, look at y is also increasing. So I have a condition where both f and g are increasing. And where is this condition? Right? And here is the condition. They are both increasing. So remember the values of x. The values of x. So from 0 going to positive infinity, both f and g are increasing. So this will be a condition for x is bigger than 0. Because I cannot say greater or equal. If I say greater or equal, this will become undefined for g. X cannot be equals to 0. It can be equal to 0 for this because we will get -2, but we have to include both. So x cannot be greater or equals to 0. We do not accept the values of x when it is 0 for the case of g, but they have to be bigger than 0. That's where both are increasing. Something just worthy of noting. Something just worthy of noting. Now I will assume that you have understood what I have said in here. Now let me move to 4.6. Describe the transformation of g to h if h at x is equals to 9 over x minus 3.5. Okay, describe the transformation of g. We are transforming g and we are calling that h, and this h is the graph of g which has been transformed to 9 divided by x minus 3.5. Now let's look at g. Let's write down the original function, which is g. We know that this is -9 over x plus 1 and half. This is what I know. And if this is what I know, I can say, okay, that's fine. The first thing that I see, the value of k was negative. Now the value of k is positive, and that will only happen if this is on the first quadrant and this is on the third quadrant. So you have to reflect along the y-axis. That's the first thing you have to do. So we can see that this is a reflection about the y-axis. That is the first transformation. And then secondly, let me try to find what this value is. This value of 1 and 1.5. So let me just come here, press my shift and write my 1.5. 1 divided by 2, and I get a value of 3.5, which is 1.5. So this is 1.5 and it is positive. Right, that's fine. Now from 1.5 to negative 3.5, so I can see that we are going down, but by how many units? That's what we have to find. So I'm going to do this. I'm going to write my y-axis there, and I'm going to place my 1.5. Where is this 1.5? This 1.5, let's say this is 0, and let's say this is my 1.5 because it's positive and it is the value of 1, and there it is. Now I want to go to negative 3.5, so I'm going to say 1.5, and from 1.5 let me say 1.5 minus 0.5, that will give me let me say 1.5. I'm trying to find an easy way for you to understand this. Minus 1.5 minus 0.5, we will get 1. Let's say 1, yes, 1. From 1, let's subtract 0.5, that will be 0.5. From 0.5, let's subtract 0.5, that will be 0, and minus 0.5 minus 1, minus 1.5 minus 2 minus 2.5 minus 3 minus 3.5. Right, so I want to make sense of this. I'm moving from 1.5 to negative 3.5, and if I use this interval of 0.5, that will be 1 2 3 4 5 6 7 8 9 10 units down. Okay, is it worthy of doing it in this way? Is it truly worthy? Is there any other method that I can try to use? Can I calculate the distance between these two? That would be another question that I will have to ask myself. So I can say I have a y coordinate. So let me say this is y1 and this is my y2, and I can say the distance will be equals to the square root of y2 minus y1 squared, and I can say my y2, it's 1.5 minus into minus 3.5, and I square this, and let me see if this will work. 1.5 plus 3.5 squared, and let's see if this works. So I will have 1.5 1.5 plus 3.5, and I square this, and I find a value of root 5. Okay, so that should tell me to take the value that is inside of the square root and say this is 5 units. So meaning we have a reflection about the x-axis and 5 units down by the distance formula. Very, very important that we see that. Highly and highly important. Right. I will also assume that we have both understood. And now let's go to question 5. Now in question 5, of course, something is given to us, h at x, which is 2 exponent x minus 4. And immediately, if we try to explain this, this is an exponential function that has some features that we will discuss as we go down into this. 5.1, they say calculate the x-intercept of h. Now I know that x-intercept y equals 0 to x minus 4 2x, and your x becomes 2. The first thing I will do, take this to the other side. I want to write 4 with a base of 2, and I know that 4 is 2 squared. When the bases are the same, you equate the exponent, and that becomes your x-intercept. So when x is 2, y is 0 as a coordinate. And then in 5.2, calculate the y-intercept of h. Y-intercept, x is 0, y equals 2 into 0 minus 4. Anything to exponent 0, the answer is 1. You get minus 3 as a coordinate. This is what you get. When that is said and done, we can go to 5.3. Hence, sketch the graph of h on a system of an axis, clearly showing the intercepts with the axis and the asymptotes. Now, this is where the explanation now comes in. Now, this is what we have, and we have tried by all means to do that which is necessary and required. Now, I can draw the function. This is my x, this is my y. Since the base is positive and the exponent is positive, it will move from the first quadrant to the second quadrant. But I have an asymptote, and my asymptote is y equals minus 4. So I'm just roughly going to say here is my minus 4, please. That is your asymptote. Okay. And you have your y-intercept 0 and minus 3. So this will be minus 3. And your x is 2. This will be your 2. And then what do? You just join everything. So this, we will approach this line but never touch. My drawing may not be as accurate as you will wish, but this is exactly something roughly that you should find. I'm very sorry for not being very neat. I'm a highly a neat individual, just that when it comes to drawing, you cannot be gifted in everything, guys. That's a belief. Right. We can go to 5.4. Write down the point of intersection between y equals 2x minus 4 and y equals what is this? 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 It looks like, oh Jesus Christ, it looks like 1 over 4x minus 4. It's not very clear because the individual who posted this question paper has this exemplar background, so I don't see clearly what is happening here. But if this is exactly what it is, we can find the point of intersection. Write down the point of intersection. So what I can do, I can say okay, this one is fine. I know at the point of intersection simply the graphs are equal, so you will say 2 exponent x minus 4 will be equals to 1 and a quarter minus 4. They are equal at the point of intersection. And you can take this to the side, this to the side, and you can say you have your minus 4 plus 4, which is a 0. That's exactly what you have. We want to get rid of this 4. We can multiply everything by 4. You will get 4 2x minus x, because this into this goes once. 1 times x is x, and this is 0. You can write this as 2 squared. 2x minus x equals to 0. You can say 2 plus x minus x equals to 0. And when you are here, what is it that you can do? he said we should find the value of x. Take to the side. Okay, and if I want to find the value, I don't know whether this is like this, guys, or whether it is not, because the individual here did whatever that he wanted to do. There's this bold on the denominator of this, so I cannot see clearly what is happening. I honestly can't see it clearly. I honestly can't. I don't even know what is written here. Now, let me not take chances because it's not clear and I cannot see clearly what is happening. Let me just leave it instead of writing something that I'm not even sure of, something that might not even be solved. Of course, we can introduce the log here and do many things, but because I'm not sure, it's not very clear, I think I will leave it at this.